In this video, I will show you how you can export your designs from TaniqWind Pro to Abaqus. For this video, I will be using the shown pressure vessel design, which has 4 helical and 4 hoop layers. In TaniqWind Pro, we allow for export to Abaqus via shell, 3D and 2D Axisymmetric models. In this video, I will show all 3 models. We will start with the shell input file option. If we click the button, the Abaqus shell input file export panel opens. In this panel, we can see several panel sections: mesh parameters, material width, element type, symmetry options, Axisymmetric layup, section points, and the plot result. In the mesh parameter section, we can set the mesh size, which is the desired width and length of the elements. The aspect ratio will stay as close to 1 as possible during computation. With the start and end position, we can select the section of the product we would like to use for the export. In the material width section, we can see the widths of the used materials. We can use this information to set the mesh size. In the element type panel section, we can select the element type we would like to use for the model. For this shell export, TaniqWind Pro allows for both linear and quadratic elements, both with and without reduced integration. In the symmetry options section, we can choose for symmetry along all 3 principal axes. We can also select multiple symmetry modes simultaneously. For the XY plane, the user must evaluate the design to see if symmetry along this plane is feasible. If there are non-symmetric paths in the design, the user will be warned with this non-symmetric path user message. With the symmetry options selected, we can see the part of the product which will be meshed and exported in the plot area. In the Axisymmetric layup section, we can choose to assume an Axisymmetric layup or not. If the off option is selected, the winding pattern is interpolated to each element based on when the tape crosses the element. The computation of the mesh and layup of the mesh can therefore take some time. With the Axisymmetric assumption on, the winding angle of the path at the particular axial location is assumed to cover the entire circumference of the product at that specific location. This reduces the computation time of the model. In the section points section, we can set the number of section points through the thickness. The standard value of 3 selects the top and bottom surfaces as well as the center. With all these settings set to our liking, we can compute the mesh. After computation, we can see the thickness plot. Within the plot result section, we can now select a layer we would like to see plotted. We can export the mesh to an Abaqus input file by pressing the export button. Now we move to the Python macro export option for the Abaqus shell. This option allows you to export the created design in TaniqWind Pro to Abaqus as an editable shell model. Unlike the Abaqus input file, which allows for toe tracking, the Python macro export only allows for the export of the design as an Axisymmetric shell. In the panel, we can see some similar settings as in the shell input file panel, like the start and end positions in the mesh parameter section. The material width section and element type section are also similar to the shell input file panel. In the mesh parameter section, we now, however, have the Z partitions and the circumferential seed parameters. With the Z partitions, we can split the product in evenly spaced partitions along the Z-axis, and in these partitions, the winding angle and layup will be the same. Within Abaqus, you can set any number of elements per partition. With the circumferential seed parameter, we can set the number of circumferential seeds Abaqus should use for creating the mesh. In the template file section, we need to provide a Python template which will be used by the software for writing the file exported to Abaqus. The TaniqWind Pro user manual provides more information on the template file. With a template file selected and all settings set, we could export the made design as an Abaqus shell model. With the 2D Axisymmetric export panel, we can export the made design as an input file for Abaqus with the assumption that all of the paths in the design are axisymmetric. This allows for true thickness, stress and strain analyzation without the need of expensive 3D models. In the mesh parameter section, we can set a mesh size to be used by the software. We can use the shown material thickness of the material to keep the aspect ratio as close to 1 as possible. For a helical layer, the layer will be split into two elements, one in plus and one in minus direction. For a hoop layer, every path in the layer will get one element. In the Symmetry options panel, we have the option to give the XY plane symmetry, since the XZ and YZ planes are symmetric by definition of the 2D axis symmetry assumption. With the information set, we can press the compute button, after which we can see the mesh in 2D with the winding angle distribution plotted in there. If we press the export button, we can export the computed data to an Abaqus import file. If we now move to the 3D export panel, we can export the design as a 3D orphan mesh. Using the 3D export panel will result in a revolved 2D axisymmetric mesh, including the assumption that all the paths in the design are axisymmetric. Therefore, the panel is basically the same as the 2D axisymmetric panel, but it has symmetry options for the XZ and YZ planes. For the 3D export, TaniqWind Pro supports linear brick elements both with and without reduced integration. If we compute the mesh, we can see the 2D mesh which is used to create the 3D mesh. With the export button, we can export the model to an Abaqus input file. We can now open Abaqus and import the 2D axisymmetric model. With importing the model, an orphan mesh will be generated. The imported part has element and node sets for the entire geometry, along with sets per ply. These are useful when results need to be queried per layer. If a symmetry option is selected during export in TaniqWind Pro, a node set at the symmetry location will be created for easy application of symmetry boundary conditions. The model has imported the material models in the correct unit system as defined in TaniqWind Pro. Orthotropic material models are used for composite plies, while an isotropic model is used for the liner. This model has only a single material used for all the layers and has no liner. The ply orientations are defined using discrete field tables. By importing the TaniqWind Pro model, two tables are defined. The first one defines the one direction and orientation of the elements, and the second table defines the rotation angle with respect to the defined element orientation. These tables are used to define the final orientation for each element in the part. This is the end of the Abaqus export demonstration video, where we've shown you how you can export your model from TaniqWind Pro, and we have shown you how your model is imported into Abaqus. If you're interested in other highlighted feature videos, these can be found at the Taniq YouTube channel.